Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on K-map. And in this video, we're going to see problems on K-map using three variable K-map, and it will be an SOP method problem. In previous videos, I have already explained the basics about K-map, the procedure you have to follow for SOP method and POS method very clearly. So I would recommend you people to see those videos first and come back to this video so that you can understand the problem very clearly. In this video, we will see problem in SOP method. We will see two problems. So the first problem is y of a comma b comma c summation of m 1 comma 3 comma 5. I've already explained the rules and regulation, but I'll also explain now by solving the problem itself, right? So from this particular symbol, we will come to know it is an SOP method, correct? So SOP method means it will be a summation, whereas in POS method it will be pi. And the very first thing is we have to determine which K-map we have to use, whether we have to use 2 variable K-map, 3 variable K-map, right, or 4 variable K-map. So now you can see here, it is very clearly said A, B and C. So it is a 3 variable K-map, right? So we will go to draw the structure of 3 variable K-map, right? And you know the structure of 3 variable K-map where we can represent this as A and we can represent as B and C, right? And now what I will do, I'll substitute these values. This is 0 and 1, whereas this is 0, 0, 0, 1, 1, 0 and 1, 1, right? And what is the next step we have to do? Next step we have to mention the positions. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6, and this is 7, right? If you don't understand how is that we are mentioning the positions, please go back to the basic videos of K-map structures, right? You can see that in the same description and also in the playlist, right? So next step what we have to do, we have to assign these values, right? According to SOP method, A is equal to 1 and A bar is equal to 0, which means 0 will be complement form and 1 will be the non-complement form, right? So here how will you write? It will be A bar A, and this will be B bar C bar, correct? This will be B bar C, this will be B and C, this will be B and C bar. Hope you can understand all these steps. And now we can able to solve the problem. Now what is the first step we have to do? Whatever values they have given, we have to substitute that position as 1, right? So what is the first one? It is 1. So I'm putting 1 in the first position and 3 and putting 1 in the 1 and 3, and then I am putting 5, right? I am putting 1 in the fifth position. Only 3 values they have given, right? The other values will be 0. Other values will be 0, right? Now what you have to do? You have to simplify, right? You have to obtain the expression, right? So how will I combine the ones, right? You have to give the maximum. So 4 is not possible, 8 is not possible here. So what you can do first, we can combine these two, correct? These two bar. So for these two bar, how will you write the output for these two bar, for these two boxes, right? For these two boxes, definitely this is only one line selected. So definitely there will be A bar, correct? There will be A bar, right? And these two boxes, so we got to check B bar C and as well as BC, correct? In this, B and B bar gets cancelled, only C will be there. So this term will be A bar C, right? Plus and the other one is left here. So, and we know that it is overlapping is possible, so we can able to combine these two. We can combine these two. If it is these two, what you can do, right? It is a and a bar gets cancels, right? So only this term, right? This term we can write it fully, right? It is b bar c, correct? Right? Now, similarly, we solve this problem, right? And before solving this, you have to understand here what is the question. Simplify the Boolean function and implement using logic gates. You have to apply logic gates for this, right? How will I apply logic gates for this? I'll draw here, right? How will I apply the logic gates here? See here, what is the logic gates? I will apply, right? You can use any method, right? Right now, what I'm going to do is I'm going to draw it here. I'm going to draw it here, right? So it is A, B, C. So we'll write A, A bar, B, B bar, C, C bar, right? This will be very simple, but now what is it is A bar and C. For your understanding, I'm writing it in detail, right? So first it is A bar, C, right? So that is a product, that is AND gate, right? So it is A bar and C alone, right? It will be a AND gate. It will be a AND gate, correct? Then second term is B bar C. That is another AND gate, right? And these two is summed here, right? And how will I do that? You can use it OR gate. You can use a OR gate here. You can use a OR gate here, correct? Right? So now we see the answer here. So you can see it's A bar C and B bar C, right? You can see that is the answer we are getting. A bar C, B bar C. Clear? Right? I'll show that slide. I'll explain that with the slide also. So this is the same method you're going to follow, right? And regarding this logic gates, what you can do is instead of writing all these things, you can write simply as A, B, C. You can also draw this in another way. I'll just explain that. In another way, how you can draw. You draw very simply. It's A, B, and C. Let us A, B, and C. First time A bar. So I'm taking A and I'm putting a NOT gate here. So if I put NOT gate, it is A bar, right? And then C. So I can put a AND gate here, right? And similarly B bar. What I will do, I'll take B and I put a NOT gate here, right? And similarly it is C. I'm taking C here and putting a AND gate here. And then you have to put a OR gate, right? You have to combine both the things. You have to combine both the things. Like this also you can draw. Clear? Right? Now we will solve this problem, the same method once again, right? So I'll just erase this logic gates. Hope you understand the concept. So now regarding this, once again what you have to, what is the first step? You have to find out which K-map you are going to use, whether it is 2 variable, 3 variable or 4 variable. From this understand A, B and C, it is understood that it is a 3 variable K-map. So if it is 3 variable K-map, what I will do, I will draw the 3 variable K-map, the structure A, B and C. Correct? So it will be 0, 0, 0, 1, 1, 0, 1, 1. And it will be 0 and 1. Correct? So now what you will do? Next thing we have to do positions, correct? 0, 1, 2, 3, 4, 5, 6 and 7. Correct? And you know that in SOP method, we will take A as 1, A bar as 0. Correct? So now what we will do? This will be A bar and this will be A. Similarly, this is B bar, C bar. Correct? And this will be B bar, C. This will be B, C. This will be C and B bar. Sorry, B and C bar. Correct? Now what you have to do, we have to put the values, right? So we got to assign 1 for all these values which I've given. What is 1 for 1? I'm putting 1 in the first question. 2, so I'm putting 2, putting 1 in the second question. And 4, and similarly 6. Right? Now, how will I solve this expression? So you see here, this is 0, this is 0, this is 0, and this is 0. Correct? Right? Now, how will I combine this expression? For combining, you got to understand here, the first box we can combine is this one. Correct? First box we can combine is this one. How will I write y is equal to, if this is up and down, so it's a and a bar gets cancelled. So only this one will be there. So it is b c bar. Correct? Right? And then one of the boxes we can combine. We can combine these two boxes. Correct? These two corners. See here, this one and this one. Right? Which means this row alone. This row alone. So it will be A is included, and then common of this box, common of these two, correct? These two corners, correct? So it is B and B bar gets cancelled, so only C bar will be there. Only C bar will be there, correct? I hope you can understand. And now this one is left alone. If it is left alone, you have to take that also, right? So that is A bar, B bar, C, right? A bar, B bar, C, right? Now you have to implement this using logic gate, same like before, right? So now we'll check the answer here. So it's B bar, C bar. So you can see here. So it's B, C bar, right? So it's B, C bar, and we have A bar, B bar, C, right? And we have A bar, B bar, C. Similarly, A into C bar, right? We have A into C bar, correct? So you have to follow the same procedure, right? And the only thing you have to understand is SOP method and POS. You have to understand this. What is the logic of SOP and what is the logic of POS, right? So now we see this problem, right? Right, very clearly here. So you can see here the same method 1, 3, and 5. You have to substitute the value 1, 3, and 5, and we are combining these two and these two, and we obtain this expression, right? And we can implement this logic gates, or else you can also draw logic gates how I explained, correct? Similarly, for this one, 1, 2, 4, and 6, you can see 1, 2, 4, and 6. So these two columns having 1, so we can combine these two and also this two and this one. This one is left behind, so we are taking that alone, right? And for implementing logic gates, you can also draw this way, or you can also draw the other way, which I said, right? You take A, B, C, right? A, B, C, right? What is first thing is A and C bar. So it's A and C bar. For C bar, I will use a NOT gate. You can use that, right? And then you can use AND gate, right? Similarly, what is that? Second term is A bar, B bar, C. So for A bar, I will put a NOT gate for A from A, and for B bar, I will put a NOT gate from B, right? And C taken. So now combining all these three, you will put another AND gate, correct? And then the last one is B, C bar, right? So it's B, and for C bar, I'll put a NOT gate, right? And again, it is an AND gate. And now you have to combine all these three using a AND gate, right? That is what they have given, right? You can also draw this method, right? So logic is very, very important, right? Hope you can understand these problems, right? And similarly, whatever problems they have given, you can follow the same method, right? So if you see this problem, it is 1, 2, 3, 5, 6, and 7. So first step, what you are going to do? You're going to assign values for all these things. So this is 1, 2, 3, right? 5, 6, 7, right? And from this block, what do you understand? From this block, what do you do? A and A bar gets cancelled, correct? So only these two. From these two, it is C, right? It's given wrongly here. So it is C. And among these four once again, these two will get cancelled. Among these two, B and C bar, C gets cancelled, so only B, right? So B plus C. And you know how to implement using gates, right? Similarly, if you take this problem, 2, 3, 4, 5, 6, 7. Put 1 for all these values, 2, 3, right? 4, 5, 6, 7. So what I can do? I can combine all these 4. If you're going to combine all these 4, only this one, right? If you take these, all this to consider all these things, it is B bar, C bar, and then B bar, C, and then BC, and then B C bar, right? So you can see B bar C bar, this two gets cancels, right? And B bar C and B C bar, this two gets cancelled. So for this one, you'll have only A, correct? So you have only A. And these four, you cannot take A or A bar, this two gets cancelled. So among these two, only B is common, so it's B, right? So the its concept is very simple. You have to use the rules and regulation very correctly, right? So today what we have seen is we have seen problems on 3 variable KMAP for SOP method. Hope this video will be very useful for you. Thank you, my dear students.